So this little video is on 3D Pythagoras. So hopefully you've already watched the normal Pythagoras video, and this is a little step up from that. Okay, so we're going to start. I've already drawn a cuboid down with a triangle inside, which is what we're going to use to find or for Pythagoras. But bear with me because drawing these is really difficult, and it's all about sort of looking at the shapes and trying to see triangles within the shapes. But anyway, okay, so the formula for 3D Pythagoras is very similar to 2D Pythagoras. So if I just remind you that 2D was a squared plus b squared equals c squared. Now 3D equals a squared plus b squared plus c squared equals d squared. So super similar, but the trick here is labelling up what's A, B, C, D. And we've also got an E, but it doesn't actually feature in the formula. So over here on my diagram, I'm going to label up these letters. So we've got A, B, C, D and E. And I'm just going to quickly go through the derivation. So I'm going to derive this equation here just so you can see, because it actually comes from two 2D triangles. So here are the two triangles. The first triangle comes from this one at the bottom here. The second one is this triangle here. And they both have E in them. So we're going to make a sort of simultaneous equation and substitute in to get the overall equation. So those are the 2D Pythagoras equations, and then because we've got an E here and an E here, we're just going to substitute that into this, and that gives us, and this here is the same as that there. Great, so that's how we derive the 3D Pythagoras equation, and now I guess the idea is just to be able to use it. So I'll go through two examples of how to use it. Okay, so here's the example. The exam question had a diagram of this, and then it told you which lengths corresponded to where on the diagram. So we end up with this. Now, the first step, as with 2D Pythagoras, is to write down the equation. Then we want to label up, so the question said find the length A to G. So if we draw out our triangle that we had in the first example, there it is. So the second step is to label up A, B, C and D on the diagram. Then we want to substitute in the values. So A is 7, B is 5, C is the same here, so C is 3, that's D squared, and then we just solve it. And there you have it. So you could do it the long way and work out and derive it, but that's the easiest and best way. Okay, now for a second example. Okay, so In this exam question, it says the diagram shows a pyramid with each sloping side 6 centimetres. Apex of pyramid is V. And here's the diagram. So it just means that all the points meet at V, and these sloping sides are 6 centimetres. The base of the pyramid is a regular hexagon with sides 2 centimetres. O is at the centre of the base. So here's just a sort of bird's eye view of the base. And each side is 2 centimetres, and here it's a regular hexagon. So find the height of V is the question. Now actually this isn't quite as difficult as the example we just did. Now we're using 3D Pythagoras, so we've just got to look for and find a right angled triangle with enough information and with the height of V, so one of the sides is OV. So we're looking for this here. Now we can just join this up here. This is a right angle, and we've got a triangle. So now we just have to find the values. We've got 6 centimetres here. This is the side we're looking for. We just need to know how long this length is here. And the good thing is if we look at our base of our pyramid, this is 2 centimetres, but all of these are equal triangles. So all these sides are also 2 centimetres. So this means we've got a triangle that looks like that. And we're looking for this side here. So we just do 2D Pythagoras here. So label up. There we go, that's just quickly run through 2D Pythagoras, and B, which is our height of V, is 5.66 centimetres. So as you can see, 3D Pythagoras can vary a lot, and sometimes it isn't even 3D Pythagoras, it's 2D. But the trick is, or you've got to try and look for triangles within these shapes and how to get there.